I'll be taking you through the AI fundamentals for business leaders. In this lecture, our focus is going to be on understanding how AI systems are built, and where the risk in AI system are. Now, to do this, I will walk you through a number of stages. I will walk you through what we refer to as the training pipeline. I will also take you through what we mean by bias. Technically, what do we mean by bias? Now, this particular lecture is one of the most important foundations in what we also refer to as AI governance. And AI governance basically looks at how the rules, the policies, and the guidelines that underpin the use, the implementation, and the impact of AI. Now, it is important that you all, before we can regulate artificial intelligence, before we can assess AI risk, or even debate about AI policy in a meaningful way, we first of all need to understand how the AI systems are actually built. So you cannot engage in discussions about AI if you don't understand how the AI systems are built. And that is the central purpose of today's session. That is the main focus of today's session. A lot of conversations about AI governance usually jump immediately into issues about ethics, issues about regulation, or even fears about AI replacing jobs. But the problem is we do not understand the underlying pipeline. And when I say pipeline, I'm referring to how the AI systems work and how our governance interventions become, or how our governance systems are superficial to that. It is important that we all understand that you cannot govern what you do not understand. So if you are a business professional, you are a chief executive, you are the owner of a business, you will not be able to regulate or govern AI very well in your organization if you do not understand how it is working. And that is why it is important for us to understand that first of all. So today, we are going to be going through the full cycle of modern artificial intelligence systems in a way that is, I would say, credible, but still technical. That is technical, but still practical in such a way that you will be able to understand it very well. So what this session does is it combines three major concepts. In this particular session, we're going to be looking at three major concepts, and we're going to be combining it into one big whole. So first of all, we want to examine what we refer to as the training pipeline. And the training pipeline, I'm basically referring to a number of steps that AI will go through before we'll be able to engage with it. And basically, it involves how raw data becomes a functional AI system. Okay, so before we can dive deeper into our major concepts, I want to give you a roadmap of what we are going to be doing today so that you can see how all the pieces will connect together. Now, if you look at the screen, you will see that there are three concept guides. And I want all of us to see these three concept guide into, as we move on, how it will integrate into one big whole. So in this lecture, our focus will be first on the AI training pipeline. The AI training pipeline. Now, the AI training pipeline is the backbone of every AI system. And when we say AI training pipeline, what do we mean? We'll look at the various components a little bit later. Then, as this is the backbone of every AI system, I want you to think about the fact that no matter what type of AI system you are using, whether it is ChatGPT, whether it is Claude, whether it is a fraud detection system, whether it is a health diagnostics tool, or maybe a facial recognition system, all of them follow a fundamental cycle. And this fundamental cycle involves the use of data, training the data, assigning weights to the data, and inference from the data. And I'll explain this very soon. Now, the AI training pipeline is very foundational because everything we are going to do as managers, it maps into the elements in the training pipeline, which we will see very soon. So it means that when you are a manager, you are a CEO, and something goes wrong with your AI, it means that one of the first questions you should be asking should be, at what stage did the problem emerge? So that if you understand, can easily ask the question in terms of the stages in which the problem occurred. And you will be asking questions like whether the problem occurred at the data stage, did it occur at the training stage, did it occur at the model architecture stage, or during the deployment. Now, the second part I also want us to pay particular attention to is what is meant by bias. What is meant by bias? And often, from now on, I want you to think about the fact that AI is biased. Now, this statement alone, when we say AI is biased, this statement, the statement that AI is biased, analytically, we will say that it's not very useful because we have to understand how technically the bias emerges. How does it happen? And how does it happen? And later on, the output we get is also biased. So we also have to understand how certain types of biasness become part of the AI system so that nothing can be done about it. We'll try to see how we understand that. Then the last part would be for us to look at three machine learning paradigms. If we have time, we'll be able to cover that. But even if we are not able to cover all of this and we are able to look at the training pipeline and even bias, we would be able to build on the three machine learning paradigms in the next week. Now, before we delve into the AI training pipeline, there are some basic things I want you to understand. For instance, when we say AI, what exactly do we mean? When we say AI, artificial intelligence, what exactly do we mean? What exactly do we mean? Now, we have to start by trying to understand how even the term AI is different from other traditional terminologies. So formally, we can define AI as the simulation of human intelligence processes by machines. So whatever we are doing, if machines are mimicking it, then we'll say that that is what? Artificial intelligence. I love this definition because it focuses on the goal rather than the method. So you look at the word simulation. The word simulation. AI doesn't need to work like our brains. It doesn't need to work like how our brain. It just needs to produce similar results, like our brains will produce. So even if we think about chess that people play, uh, uh, programs that are designed for purposes of chess, they don't contemplate moves in terms of the way the humans will do, but they will come out with the same outcome. So artificial intelligence can be largely rule-based, but the fundamental thing is that artificial intelligence basically mimics our human intelligence functions. Basically, that's what it's doing. And it involves the issue of reasoning, problem solving, perception, and even understanding of what? Of languages. And there are different examples of artificial intelligence. Virtual assistants. If you are using an iPhone, Siri is a typical example of an artificial intelligence. You press the button on your phone, you talk, and your phone responds. Sometimes customer service chatbots. You see a chatbot, you type a message, and then it responds in a way as if someone is sitting behind the screen. That's a typical example of what? Artificial intelligence. Now, let's try to juxtapose this term, artificial intelligence, with other terminologies. Some of you may have heard of the term machine learning or deep learning. and artificial intelligence. How are these terms related to each other? Now, if you look at this diagram, it is illustrating the relationship between artificial intelligence, machine learning, and what we refer to as deep learning. And to understand that, let me walk you through it. If you look at the diagram, you will see that AI is the broadest category, the blue outer circle. And it includes rule-based approaches like expert systems and knowledge bases. Then we also have what we refer to as machine learning, and that's the green middle circle. The green middle circle is a subset of AI. And here, systems improve through experience rather than programming. So when you hear machine learning, it means computers or machines are based on a particular system and they are able to adapt by learning through what? By learning through experience rather than explicit programming. So someone would have programmed the machine, but as the machine is continuously working with some kind of data, the machine learns certain things. And usually these things are what? Are patterns. Then we also have what we refer to as deep learning, and that is the inner circle, the orange inner circle. And deep learning is a specialized subset of machine learning. And this particular one, deep learning, uses what we refer to as neural networks. And it has different multiple layers. So you see that artificial intelligence is the broader concept. So when you hear machine learning, when you hear deep learning, all of these are subsets of what? Artificial intelligence. All of them are subsets of artificial intelligence. Now, I have, in a simple way, explained machine learning, but we can drill down to machine learning a bit more. And as I have indicated, machine learning sits in the middle of our hierarchy between deep learning at the bottom, and then there's machine learning in the middle, and then there's a broader one, which is what? Which is artificial intelligence. Okay, so this is just a basic understanding of these three concepts so that you can see how artificial intelligence fits into this broader, these three concepts. Now, zoning down to particularly what we are interested in doing today, trying to understand a particular concept. And the concept I am introducing is the training pipeline. The training pipeline. And I want you to note this term. Because if there's one thing I want you to remember from our session today, it is the term training pipeline. At the end of the session, if you forget everything, don't forget the term training pipeline. It is important because almost every major issue in AI or AI governance, it is traced to the pipeline. Every major issue in AI is traced to the pipeline. And the pipeline has got 4 major components. And the components are 1, training data, 2, training process, 3, model weights, and then the last one is what we refer to as inference. So every AI system we come across would have these components. It will have a training data, it has a raw data. It will have the process that is used to train the data, and then each data is assigned some weight. And we'll explain each of these components as we go on. So I'm saying that every AI system follows this pipeline. It doesn't matter what type of AI we are discussing or we are confronted with. Every AI system follows this pipeline: training data, training process, model weight, and what? And then inference. So what we're going to do is to delve deeper into each of these components. Now, when I was going through the course outline, I indicated that you cannot govern what you understand. So if you are a manager or a CEO and you want to implement an AI system, you need to understand it first, the AI system. Otherwise, you will find it difficult governing this particular system. And for you to be able to understand the AI system, what do you need to understand? You need to understand the AI pipeline. The AI pipeline. You need to understand that. Because it is only when you understand the AI pipeline, and the AI pipeline is universal. Everywhere you go is the same thing. Because every AI system, from the smallest say, the spam filter to frontier models like ChatGPT-4, Claude, and whatnot. They all follow this basic pipeline. So once you understand the pipeline, you can analyze almost any AI system from governance perspective. You can analyze anything. So there are three key ideas here. First, everything we are regulating is at a particular stage of the AI pipeline. You get that? So now I want us to pay particular attention to and this is how the AI pipeline looks like. Here's how it looks like. Stage one. Stage one is what? Training data. Stage two is the training process. Stage three is model weights. And stage four is what we refer to as inference. Maybe I can help you for us to get an acronym out of that so that we never forget it. So training data, training process, model weights, and inference. So you have T in the first one. Then the second one, maybe we can call it P. Then the third one, we can call it W. And then the last one, we have I. So we can have T, P, W, I, which means training, process, weights, and what? And inference. And I want us to take some time to go through this carefully. So this particular slide it gives us a complete AI pipeline in one framework visually. And I want you to use this to remember it. So, and as I'm emphasizing, if you don't remember anything from this lecture, remember these four things: training data, training process, model weights, and inference, because everything in modern AI fits somewhere within this pipeline. Now let's go through it one after the other. If you look at stage one is the training data, and this is the raw material the model learns from. So every AI system you can think of starts with what? Raw material. And the raw material is what? The data. Now, this raw material or data could be what? It could be books, textbooks, right? It could be websites. It could be codes. It could be images. It could be medical X-ray files and many, many other forms of what? Other forms of data. Now, if we want to describe the training data as maybe a textbook, we can look at it this way using a scenario. You see, you are students and you learn from textbooks, right? So AI systems also learn from what? Data, which is its textbook. Then we move to the stage two. Stage two is actually where the learning is taking place. That's the learning phase, where the model will repeatedly analyze the data. And as it is analyzing the data, the model will be adjusting to improve what? Improve its performance. It's just like you as a student. If you pick a textbook, you learn, you read it. The textbook is your raw data. When you read it, you try to see if you can remember. If you cannot remember, what do? You go back and read again. And that is exactly what AI systems do. That is the staging phase. The model, that is where the model is making predictions. It is trying to measure its what? Its errors. And as it is determining or understanding its errors, continuously the data will be updating itself. And it will do this over millions or billions of what? Iterations. When we say iterations, it will be going back and forth, trying to remember, trying to learn, trying to remember, trying to learn. And that is the training process. Then we have the stage three. The stage three is where we have the model weights. Here, everything at all the AI learns, the AI will try to do what? Store it as its knowledge. Now let's look at it in terms of you as a student. Whatever you learn from your lecture, whatever you learn from a textbook, you store it in your brain after studying. Now, when we say weights, these weights contain everything you have learned from the back and forth you were doing. But whatever you have learned, you have assigned importance to some of the things. So it's like when you are going into an exam, you think that, oh, this is likely going to come. This is not going to come. What you have basically done is to assign what we call weight to whatever you have learned. And the AI model also does that. It also does that. Whatever it learns, it categorizes them in terms of importance, and it will assign weights, numerical values to them. And these numerical values are what we refer to as what? The weights. And then finally, we get to the last stage, which is the inference. This is where the model, the AI system is interacting with me and you, the users. So for instance, if a user asks a question using AI by uploading a particular image or typing something, what will the model do? The AI model will generate output. You get that? And it's the same thing. And that is the exam phase where it is very critical for the AI to try to remember what it has learned. So you ask the AI a question, then it is trying to remember what it has learned. In answering your question, the AI will look at the ones it gave stronger weights and pull it and give it to you as an answer. The AI will do what? It will pick the ones it has assigned bigger weights and give it to you as an answer. So first, raw data. The AI will go back and forth and learn it. When it is learning it, it will be given some importance, some less important. And then when you ask it question, it will go to the ones that it considers to be very important and give it to you as the answer. And that is how the training pipeline, every AI system follows this particular pipeline. Now, I want us to move on to look at the training data in detail. I want us to look at the training data in detail. And to do that, we are going to revisit each of the steps in the pipeline. So the first stage in the AI pipeline is what? Training data. And this is where everything is starting. So we are saying that the composition of training data determines what the model can do or it cannot do. So if an AI was not fed with some data at the beginning to train it, if you ask it a question, because the answers were not contained in the training data, the AI cannot answer it. The same thing applies to a student. If you ask a student a question and the student never learned it, he cannot answer it. You get that? So everything begins at where? The training data stage. The quality, the composition, the diversity of the data, all of this will determine what the AI system can do and what the AI system cannot do. So if a model is trained mostly on English data, then it means the model cannot do anything in Dagbani. You need to understand that. If a model is trained on English data, if you ask it a Dagbani question, the model cannot provide anything. It was not trained on any Dagbani data. I hope you understand. So when we say data, the data comes in different types. It comes in different types. So we can have text, which will be like books or web data, Wikipedia data, news published online, information published on forums. Then we can also have labeled data sets. So assuming you have taken a lot of pictures and you caption each of these pictures, that is also is an example of a labeled data set. Then we also have tagged reviews, we have scans, x-rays, diagnosis, and all that. These are examples of what? Labeled data sets. Then we also have what we call code repositories. If you go to GitHub, for instance, you'll find a lot of codes there. Stack Overflow, documentation, all of these are examples. Then we also have another type of data is what? Human feedback. Human feedback. So we have different kinds of what? Data. And the data will include text corpora, which include books. Then we also have labeled data, we have code repositories, and we have what? Human feedback. Now, the question I want to ask you is, if data is a copyrighted material, somebody has written his book, can you put it into AI without the person's consent? If you do that, there's a problem because you didn't get the person's consent, and that will raise a copyright issue. You get that? The same thing, if a particular data like images are not labeled properly, if they are not labeled properly, it can also cause a problem because the AI will pick the wrong label and learn it. You get that? If there's a problem in a code and you put it in the AI will not correct it. It will pick the code like that as raw, the wrong code as raw data and learn the wrong thing. You get that? The same thing, if you are writing your notes, like I am teaching, you are making notes, and you don't write exactly, and you write something wrongly, and you go and put it into AI to train the AI model, the AI will use your wrong data. You get that? Now, what happens is that if you feed AI with wrong data, it will give you what? Wrong output. Over the years, you may have heard of the term garbage in, garbage out. And AI works the same way. If you feed it with wrong data, if you train it with wrong data, the AI will be giving you what? Wrong outputs all the time. So what I want you to remember from this slide is that every problem in AI is traceable to what? To something fundamental, the training data. And if an AI is lying, it means the training data, there were lies in it. If AI is biased, it means in the training data, there was biasness in it. And you have to understand that everything about AI starts at this particular stage, the training stage. Now, stage 2. As we move into the stage 2 of the AI pipeline, you will realize that during the training process, also referred to as the training loop, the model is learning. This is where the model is learning. This is where the AI model learns. How does it learn? It learns from patterns from the data because at its very foundation, training is repeating back and forth, millions of iterations. Now, what actually happens is that at the training stage, a number of things happen. 4 things happen at the training stage, 4 things. Now, the first thing that happens is that there's what we call forward pass. And this is where the model will receive an input and make a prediction from it. So it's usually random at this particular stage. So the moment we give the data to the AI, that is this at this particular stage, the forward pass. Now, as the AI takes the data as the first stage, the forward pass, it receives an input, and then what does it do? It tries to generate a prediction. At the beginning of this training, those predictions are basically what? Random, because the model has not learned anything yet. You have just given it to it. And that's what we are saying. That's why it is called forward pass. You just pass the data to the AI. Now, the second thing the AI then does with the data is that it moves on to the what? The loss function. Here, the AI system will now be comparing the prediction against the correct answer. So you have given it data, then it will now be picking randomly and be correcting, trying to learn from it. And as it is doing that, it is calculating how wrongly it is doing it and how rightly it is doing it. So it is even able to say that, oh, there's an error score because the AI cannot be perfect. And you have to understand that when you give AI the data as forward pass, it will make a lot of mistakes. And it is at this stage that we call the loss function. As it is making the mistakes, what does it do? It is learning. The error at this particular stage is what we refer to as the loss. The loss. The error score is the loss. Now, as the AI is realizing that it is making mistakes from learning the data, it does something very important. It moves on to the third stage, which is called the back propagation. And back propagation is where the system is working backward to determine which weight contributed most to the error. And it is going to be assigning weights to every item, how important every item is. So at back propagation, the system works backwards, back and forth, and determines which weight is contributing to the loss or the error. In simple terms, back propagation basically is asking a question like, which part of my internal structure caused me to make this mistake? So if I am a student and I learn something and I go to the exam hall and I cannot remember, after the exam, I'm going to be thinking, so what happened and I couldn't remember? 1, it's possible that the environment was not conducive. 2, I panicked. Because I panic, I can forget everything. So the process of going back and forth and thinking That is the process we refer to as what? The back propagation. Now, if I write my first paper and I realize that because I panicked, that's why I forgot. In my next paper, I will try and make sure that I don't panic. No matter the intimidation, I'm not going to panic. And if I do that, it means that I have learned from that experience. And that back and forth experience is what we refer to as what? The back propagation. Then the final stage is, initially, I think I mentioned the fact that when we give the training data to the AI, and the AI, that is a forward pass, the AI try to assign some weights to it in terms of importance. This particular thing is very important, so 1. This particular thing is very important, so 3. But as it is going to make a prediction, it is going to make mistakes. So the fact that it assigned some 1, some 3 may have led to the mistakes. Then it will go back and try to reassign them, back propagation. Now, the assignment of these numbers, those tiny adjustments, they accumulate over time, and gradually the AI will improve in its performance. Gradually, the AI will improve its, and finally it will update its weight. Finally, it will update its weight. So this is how the training of the AI happens. Then the stage 3 is where everything actually falls into place, where the model weights are properly assigned. This is where the learning it has undergone through the training is stored here at this particular stage. All the learning is now saved. The model weights are now concretized. The model weights, the importance the AI assigns to the things are now finalized. So, for instance, if the training data is a textbook, and we are saying that training process is your studying approach, then it means that the model weights we are talking about here is the knowledge you put in your brain after learning. Basically, that's what we're saying. So if the first one is the textbook raw data, the second one, the training process is studying. The third one, the model weights are the knowledge you are storing in your brain. And this is where we are. So a modern AI model contains a lot of parameters or a lot of weights. And these weights can be millions and millions of them. To the extent that if you look at ChatGPT 4, it had 1.8 trillion weights in them. And we are saying that these weights are actually the knowledge that is stored after the model has learned. So it means that if you, as an expert, you are able to steal an AI weight, you have stolen the whole AI model, because that is where the learning is stored. So mostly AI models, they don't disclose to anybody the model weights, because the weights is the stored knowledge. And if anybody gets access to the model weight, the person has stolen the AI like that. Okay. So this is the third stage. Then the fourth stage is the inference stage. And this is where most of us are engaged with AI. When we get to the inference stage, the AI is no longer learning anything. So at the point me and you, we are interacting with AI is not learning. It has finished learning. Now we are interacting with it. And when we are going to interact with it, what do? We as users will input, we will submit a prompt, we will submit a query, we will upload an image, or we will put a data point. And the AI will do what? It will process it. It will process it. Then it will now go back looking at its weight, which one is more important, then it will give us the output. And that is what we see on our screen as what? The delivery. The output is returned to the user or downstream system on our screens. So basically, AI systems work through 4 stages. Stage 1, training data, raw data. Stage 2, training process. Stage 3, model weights. Stage 4, inference. And the inference is the final stage that we interact with what? With the AI. Now, in terms of governance, if you are a manager or a CEO, how then do we relate this to governance? So this particular slide brings everything together. in terms of what we have discussed before. So what we now have on this particular slide is what we refer to as a governance map. And this governance map is for the entire AI life cycle. And here the key idea is very simple. If you look on the left, you will see training data, training, model weight, and inference. This is the stages of the AI pipeline. But at each stage of the AI pipeline, there are risks. And there are things we can do as managers. There are laws that govern them and what the laws are expecting us to what? To do. So a typical example is if you look at training data, if I go and pick data, and the data is just, it consists of only one tribe, say Mampusis, data regarding one tribe. If I use that as my training data and I train my model and the model assigns weights, anyone who interacts with the model, the model will be returning what? Data regarding Mampusis. So if you go and ask it a question regarding the Bombers, the model will what? It will lie. It will give you Mampusi response. And in that case, the model would have been biased. And that's a problem. The model is biased because the data that was used to train the model was biased. And that is why it is important that we as managers, we as business professionals, the kind of data that is used to train AI is important to us. So that when we need to understand that, because when people are talking about AI being biased, then you, as somebody who has undertaken this course, you know that the AI is biased because maybe the data they used to train it was biased. That's how you explain to people. The data that was used to train the AI, if it is biased, the AI will be given biased data. You get that? Okay. Now, the key idea here is straightforward. We are saying that every major AI risk, every regulation belongs somewhere in the pipeline. That is what this table is basically telling you. And if you take the first one, that the training stage, the major risk here include bias, copyright, privacy, and even the issue of underrepresentation. So if you go and pick somebody's material and you put it into AI without that person's consent, you have infringed on the person's copyright. If you go and pick somebody's data without his consent and put it into AI to train the AI, you have violated the privacy of the person. So there's a risk there. And people do that. People collect different kinds of data and they use it to train AI models. Okay, so at each stage of this, there are governance challenges, that there are risks, there are key regulations, and what we need to do. So for instance, if an AI is trained with biased data, we as managers, our intervention would be for us to conduct an AI audit. And to conduct an AI audit, you need to try and ask those who developed the system to show you the data that was used. Now, when they show you the data and you realize the data consisted of a particular tribe, then you know that the training data itself was biased. That is why the output that is being generated by the AI is also what? It's also biased. Okay. Now, let's look at this scenario as an example to explain or bring into context what we have been discussing so far. And I want us to apply the pipeline framework to a real governance scenario. And this is what we're doing. We're going to do. This is a European healthcare artificial intelligence, but this is something, a healthcare AI system, which was developed in Europe, but it is being implemented in where? In West Africa, in Ghana. And this is the scenario. Imagine a hospital in Accra, and this hospital in Accra procures a clinical diagnostic system, AI system. But this system was developed where? In Europe. And it was trained mostly on European patient data, white man data. Now, at a first glance, the system may appear very highly accurate and very technically impressive because it is coming from Europe. But once we analyze it through the pipeline framework, then immediately we will see a lot of issues emerging from it. So the first thing we should start asking about this particular AI system, which was developed in Europe and trained on European data, is that We have to start asking questions about the training data. And if you look carefully at the slide, problem, the patients in the data set differ genetically in disease prevalence and healthcare context from Ghanaians. So if you bring the AI to Ghana to use it to diagnose our diseases, it's going to be a problem because there will be bias. There will be selection bias. There will be representation bias. So as a professional, what are you supposed to do? Your intervention will be that you need to audit the data set composition and ensure that the data, you need to look at the data. And if you look at the data, you will know where the biasness is coming from. If you also look at the way it was trained, the problem is that the model was never trained on what? Ghanaian data. It has never seen the population and the conditions it has been brought here to what? To diagnose. You get that? Now, if you look at the model weights, the problem will be that the one who developed it, he's the one controlling the weight and the knowledge of the AI. The hospital cannot inspect or modify them because he developed it over there. If you look at the last one, the inference stage, the problem will be that the doctors, the clinicians, they may follow incorrect recommendations, and patients would have no easy way to challenge their decisions. And when that happens, people will be taking wrong medications because of the biasness in the original data, because of the training, and because of the weights assigned. And all of this can lead to a lot of accountability issues, a lot of discrimination, and what? And a lot of harm. So, assuming I give you a scenario like this, and I ask you to analyze it based on the AI pipeline, my expectation will be that you try to understand what the training data was. Where was the model trained? Which kind of data was used to train it? And then how was the training done? The model weights, and then the inference. But the fundamental thing is for you to understand the kind of data that was used to try to train the model, because that is where biasness, that's where discrimination and a lot of ethical issues can evolve. So this brings us to just the first part of our lecture. And I just want to stop here and take a step back to take you through some of the terms I have mentioned in the last 40 minutes. So this particular slide contains some of the most important things you will be coming across in our discussions. I want to emphasize that you don't need to become an expert overnight, but you need to be fluent with some of these terms. So when we say training data, basically, we are looking at the data that is used to teach a model, the data that is used to determine the model's capabilities and biases. Then I also mentioned the term model weight. What does it mean when we say model weight? Model weights are the numerical values, the numerical values that are stored or that store what the model has learned. That's the model weight. In many ways, the weights are the actual AI system. So if someone is able to steal a model's weight, then he has stolen the system. So when an AI system is developed, they hide the weights because the weights are the knowledge or the brain of the AI. Then I also mentioned a forward pass. Forward pass. A forward pass simply means running input through the model to generate an output. Running an input through the model to generate an output. That's a forward pass. Then I also mentioned loss functions. And I said that the loss functions measures how wrong the model prediction is. How wrong the model prediction is. Then I also mentioned back propagation. And I indicated that back propagation is basically the mechanism that the model will use to figure out which weight contributed to its loss or its error. And I said that this is how the system learns, by going what? Back and forth. And other terms include learning rate, how much the weight can be adjusted after every update. Then we also mentioned the term inference, and we said the inference is the large stage of the models. The inference is the large stage of the models, the AI pipeline. The inference is at the large stage of the models, the AI training pipeline. Now, going forward, some other terms we will come across involve hallucination, prompt injections, flops or floating point operations, which are used to measure the computing power of the AI models. We also come across terms like foundational model. We also come across terms like data drifts. So going back just a little bit, I want to go back to the AI pipeline. And I started off by saying that at the end of this lecture, if you don't understand anything at all, you need to understand that for every AI system, there are 4 stages. And you can always use these 4 stages as the analogy to analyze any AI system. And we indicated that the first stage is the training data, the raw material the model is learning from. And if you are a student, the raw material in your case will be what? The textbook. So we indicated different types of training data. And we indicated that the training data can be what? It can be text, it can be images, and what have you, audios and what have you. It can also be codes or code bases. Then we also mentioned the fact that the training data at stage 1, the next stage is the training process. And this is where the learning actually takes place. And at the training, at the stage 2, there are several billions of iterations that go, the back and forth that goes on. And we indicated that if you come to the training stage, there are 4 stages: the forward pass, the loss function, the back propagation. This is where it happens. Then we also indicated that whatever a model has learned, the model assigns weights to it and stores the weights. The backbone of every AI system is its weight. If someone has access to an AI model's weight, the person has stolen the AI. And so every developer, every AI system's weights are secretly what? Guarded. But there are open AI systems that you can find. If you go to GitHub, you can find several AI systems which are open source. It means that for those AI systems, the model weights are what? Are made available. The knowledge base of the AI system is made available. Then the last stage of the AI pipeline is what we refer to as the inference. This is where the model is deployed. This is where the model is deployed, and this is where we interact with the model. And the inference stage, we also indicated that at the inference stage, the model is no longer learning. Nothing is happening there. The weights are frozen. The weights are frozen. So you cannot continuously use an AI and say that the AI has learned what you are doing. The AI may just be recalling what you have fed into it, but it is not learning because the model weights have been frozen at that particular stage because it has passed the training stage. Now, you also have to understand that what I'm saying is, I am not saying that your data and whatever you have fed into the AI cannot be harvested and used to train the AI model. It can be done. But as you are interacting with it, the model is not learning anything. But whatever you have fed into it, the developers can scrape off that data and use it to train the model again. And the model can become what? Can become more powerful. And all this will lead to the training process again, the adjustment of the model weights. And then when inference is happening, user input, processing, and outputs will be completely different because a new learning would have taken place. So this brings us to the end of our first session. The critical thing is what? The AI pipeline. The AI pipeline and how the AI pipeline influences a lot of issues in terms of governance, in terms of risk, in terms of ethics. Let me see if I can pull up the yes, this. Yeah. So if you look at this, at every stage of the AI pipeline, that is training data, training process, model weights, and inference, there are a number of risks. There are a number of risks. So even at the last stage of the AI pipeline, at the level of inference, the AI can make a mistake by hallucinating, by discriminating, by violating privacy, by manipulation. At this particular stage, we say that the AI is not learning. But there's a risk at the model weights stage because the model weights can be stolen, and that's a risk. The fact that people can steal the weight, there's a risk there. So if someone steals a model weight, they have stolen the AI. Now there's also the issue of proliferation. Someone in the organization that developed the AI can steal it and mimic it somewhere else, give it to other people. Now, usually handling AI weights, especially in organizations where there are a lot of stakeholders, partnerships, and whatnot, the way AI weights are handled can lead to a lot of intellectual property disputes. It can lead to that. Now, risk at the training stage involve a lot of issues regarding capability of the training model and safe optimization and resource concentration. If we don't have a lot of resources, it can influence how the training is done. Because if you don't have a lot of compute power, your training process can be what? Can be compromised. Then we also have the issue of training data. And we said this is the backbone of everything. This is the first stage. At this particular stage, a lot of things can creep into the AI. A lot of things can creep into the AI. And there's a case study I will be giving to you to look at. And this case study has to do with Amazon. Amazon contracted an organization to develop an AI recruitment system. And this AI recruitment system was fed with data over the years, 10 years data. And this 10 years data consisted of data regarding recruitment into IT. And a lot of the data showed evidence that a lot of the people who were recruited over the years were male. So the inference behind the data was that a lot of IT roles were male dominated. Now, this particular data, the 10-year data, was used to train the AI model. Now, when the AI model was deployed, the AI was discriminating against female applicants. The AI was discriminating against female applicants. I want to ask you, throw a question to you. What do you think may have caused the AI to discriminate against female applicants? And how could this have been avoided? Were you guys listening? How could this be avoided? The AI was discriminating against. How could this be avoided? Or how can this be correct? How can this AI model be corrected? And what are the issues this AI model raises. Yes? Do you understand my question?
Yes, Prof, we do.
Okay. So, yeah, Hashimoto indicates that it was fed with wrong and biased data at the training data stage. Excellent. So there's nothing they could do. The fact that it was giving them wrong output was because they trained it with biased data. So originally, it is not the AI system per se that is biased, that was biased towards women. It is because the data that was fed into the AI to train it was biased. You get that? So in order to deal with bias in this particular case, what do you think should be done? How can an organization deal with the issue of bias? Look at the first one, training data. It was bias. And there's a key regulation, the EU AI Act Article 10 is talking about biasness and whatnot. But we are also saying that at the extreme right-hand side, when there is a problem with the training data in terms of biasness, copyright issues, privacy and representation and whatnot, it can only be revealed through data audits or the data sheets that was fed into the AI. If it is regarding the issue of privacy, we have to ask for what? The consent forms that the people filled. In terms of biasness, data audits would have revealed that. And so for Amazon to have corrected the issue, they would have to go back to data to get other data that can what? Correct the biasness. Otherwise, the AI will continue to be what? Biased. And there are so many AI systems across the world that are using biased data. And I'll give you a typical example. When ChatGPT first came, and I believe maybe it still does, if you go into ChatGPT and then let me stop record and then just take you through some practical